Hi, here we have to evaluate limit extends to infinity 2x square positive 5x positive 2 over 3x square positive 7x negative 4. Okay, so whenever I want to evaluate limit where the variable x approaches infinity, actually infinity means it's positive infinity because the sign of infinity is not mentioned. So I have to assume it's positive infinity. So whenever a variable approaches a positive infinity, this kind of problem. So what we need to do is the given function, just look at the largest exponent in numerator and largest exponent in denominator. That is the degree of the numerator, degree of the denominator. So the largest exponent of the numerator is just 2 and largest exponent of the denominator is also the same 2. So now the first step what we need to do is we have to factor the variable x with the largest exponent from numerator and denominator as well. Okay, let me do that. So limit x tends to infinity. So the variable with the largest exponent in numerator is that is x square. So x square has to be factored out in numerator. In denominator also, the largest exponent is 2. So we have to factor the variable x with the largest exponent 2. So we have to factor x square in denominator. Okay, if I factor x square out from the expression numerator, what will I get over here inside the parenthesis? So to know what we have left in numerator, just have to divide each term in numerator by the one I factor out, that is x square. So I'm going to divide the first term 2x square by x square. Positive 5x over x square, positive 2 over x square. And in denominator also I have factored x square out. So to know the stuff inside the parenthesis, I have to divide each term in the expression in denominator by x square. I mean by the one we factor out. So first I divide the first one 3x square by x square, positive 7x over x square, negative 4 over x square. Okay, so here this x square will cancel out. Here x square will cancel out. Here x square will cancel out. Okay, when I simplify x over x square, what will I get? So when I simplify x over x square means like x over this x square can be written as x times x. This x will cancel out. I get 1 over x. So the simplification of x over x square is just 1 over x. So that means x will cancel. Just have in x square, 1x will cancel, we'll have x left in denominator. The same thing over here. Okay, limit x tends to infinity. And we have 2 in numerator, positive 5 over x, positive 2 over x square divided by, and here we have 3 left, positive 7 over x, negative 4 over x square. Okay, now that's all the simplification we can do. Now we can plug in the limit for x into the given function. So when I do so, just a moment. Okay, I'm going to plug in x. I'm going to plug in the infinity for x. So 2 positive 5 over infinity, positive 2 over infinity square over 3 positive 7 over infinity, positive, negative 4 over infinity square. Okay, here 2 positive. So 5 is a finite value and infinity, I've told you it's a positive infinity. Positive infinity means it's a very large positive value. When I divide a finite number, a very large positive value, so it will be very close to 0. So we can, the result of this one is going to be 0. So for example, if I divide 1 by 10, what's happening? 0. When I divide 5 by 10, what's happening? 0.5. When I divide 5 over 100, it will be 0.05. If I divide 5 over 1000, it will be 0.005. So if I keep increasing the denominator, that is the denominator is getting larger and larger. So what's happening in the value of the fraction? So look at here, it's getting smaller and smaller. At one stage, when I take a very large value as denominator, so the value of the fraction will be 0. So that's what, so when I divide a finite value 5 by a very large positive value, so the result is 0. Okay, here infinity is a large value, large positive value. When it is squared, again, it will be a very large positive value. When 2 is divided by a very large positive value, still it's 0 over 3 positive. The same thing we have for 7 over infinity, that is 0, negative. So the same thing we have for 4 over infinity square, that is 0. So when I simplify this stuff over here in numerator, it's just 2, and in denominator we have 3. So the evaluation of the given limit is equal to 2 over 3.